In this video, I'll be talking about the linear momentum conservation law. The total momentum of objects that interact do not change. In this law, it states that the amount of momentum is the same before and after the objects interact. So for example, if something's going 50 miles an hour and something's going 25 miles an hour in the same direction and they interact, they are gonna transfer the energy to one another. The total momentum remains constant and is conserved unless outside forces act on the object, for example, friction. Momentum is a sum of mass, the sum of the mass of an object times the velocity. Linear momentum is always conserved with every collision as long as the objects are the same mass. So P equals mv, which is mass times mass of an object times the velocity. And if the objects are the same mass, this should mean that they are elastic. Therefore, initial momentum should equal out to final momentum, as I wrote Pi and Pf. And I also wrote about elasticity. So collision at the same mass has the kinetic energy constant with no speed lost, but if they are different masses, kinetic energy is definitely lost. Therefore, changing mass equals loss of elasticity, or it makes it inelastic. I selected this specific problem because I believe it shows what the linear momentum law states in more than one way, such as mathematically and visually. So the question I chose is, what is the final velocity of a bowling ball 2 after it had an elastic collision with another bowling ball of the same mass if its final velocity is 0.5 meters per second? So I drew out some bowling balls while I copy and pasted them, and it gets the point across. So it's not perfect, but they're at the same momentum before and after the collision. So if ball one hits, say, at 2 meters per second, and this ball moves negative 0.5 seconds, or meters per second, this ball over here, so that was ball one that moved 2 initially, but that means it's going to transfer the energy, and this one's going to move 0.5 and the other one's going to move 2 meters per second. So how will I go about solving this question is I need to have some mass and velocity. So the mass of the bowling balls, both of them, are 6 kilograms. So right here, M1, I forgot how to do that because the capitalized stuff. M1 is the mass of bowling ball 1, and M2 is the mass of bowling ball 2. The velocity of bowling ball 1, though, however, as you could tell, it is 2 meters per second on bowling ball 1, and it's a lot smaller. So this would be the negative 0.5, and vice versa. The opposite happens over here. So you will do M1V1 plus M2V2 equals M1V1 with a in M1V1, I'll call it 2, and M2V2 2 because they're different than the first ones. But whenever I plug everything in, 6 times 2 is 12, 6 times negative 0.5 is negative 3, 6 times 0 is 0, 6 times 1 is 1. Well, 6 times V2 is 6V2, 2. And therefore 9 equals that. And then when you actually divide 9/6 equals V2 number 2, you get 1.5 meters per second as the final velocity of bowling ball 2. And that concludes my presentation. Thank you.